I'm John Metzger. I'm yet another cloud solution architect at Microsoft. I've been doing stuff with the Midlands Azure user group pretty well since it started, not quite the first session. And those that have seen me, I tend to do more developer rather than infrastructure related topics. And that's kind of why I have this app innovation thing. Is digital and app innovation is the name of the team that I sit in at the moment. And right now I'm helping sort of public sector type customers, but a lot of this stuff is applicable to all sorts. You letting them in, Phil? Yeah. So there'll be a few slides here, but also some demo stuff. So as kind of Phil intimated, I was going to be doing a different session, but we realized that product wasn't yet out of private preview, so it was probably unwise to talk about it. So apologies to those that were expecting a different session, but I hope this one's kind of has a certain amount of interest to it. So to move on things. So what's in it for me type thing. What might you find useful? So firstly, if you come across any kind of classic ASP apps, some of these really old ASP apps, and you kind of need to have those on Azure, but you don't want to effectively do an infrastructure lift and shift. This tells you about a recipe for doing that. So it's about basically how to make it really easy to use platform services to host classic ASP apps. And for those that aren't platform and are infrastructure types, it will hopefully also give you some insight into how platform services work and how they can give you a leg up in terms of getting some relatively old app on Azure. So I'll quickly go over, the ask I had from this specific customer that I did this for. So this isn't stuff that we've just made up. This is the result of some actual stuff that I did for a customer. Go through, what classic ASP is, because people might not remember how we approached it. And hopefully the chunk of it will be some actual, demo stuff, so you can see stuff working. It's a bit more interesting than PowerPoint. So the customer had a number of vintage ASP applications. They were sitting on IIS on some old machines, back-ended by a SQL server, and having had a little bit of Azure training, the customer did. They thought to themselves, well, we like the idea of platform services because with platform services, Microsoft take more responsibility than to run them than for infrastructure services. And so that sort of division of responsibility is, if Microsoft take on more, you as the person deploying and operating the service have to do less. So, that's kind of a good thing. And we're quite good operating infrastructure at scale. Everybody else is also quite good, but we do a lot of it, and so doing stuff at scale is kind of easier for us. So the other thing is that this customer, besides little Azure experience, had no kind of DevOps experience either. So remembering classic ASP, it was never called classic ASP in the old days, just like classic Coke wasn't called classic Coke. It was just called active server pages. And it goes back into 1996 when I looked this up, the v1.0, and the final one in 2000. But some of this stuff is still hanging around, and I've got a little bit here where you can see it's kind of a horrible mixture of little bits of code in brackets. Alongside, I haven't put nice little HTML tags around that, but effectively it munges together the HTML that it finds in the page with the stuff that comes out of the code. And so, for example, you do a bit of SQL, that will generate a piece of text which will get inserted into the page. There's no model view controller stuff. There's no structure other than any structure people impose on themselves. So really quite old stuff. but amazingly, there is quite a lot of this stuff still around. I went to this site here only a week or two ago, and you can see it's starting to tail off. This little graph here is starting to tail off, but it does mean that there's almost 50,000 in UK, and there's quite a lot of stuff around. So it's not as if this stuff doesn't exist anymore. It's amazing how a lot of this stuff sticks around, and how hard it can be to move this stuff. And the other point that the customer wanted to do is they didn't want to rewrite everything. Yeah, and most customers don't want to re-architect and rewrite if they don't have to. Can you take almost exactly what's there right now and get it on Azure? So now we're stepping a bit more into the technical detail of what's going on, and the customer said they like platform services, and the nice big web app symbol there is because the kind of the main service that we have on Azure is app services for delivering and hosting web apps. Sometimes we call it app services, sometimes we call it web apps. I think it started off as websites, but hey, we love changing the name. So a lot of this talk is going to be about how to get this stuff onto app services. Now, interestingly, app services can actually run a really, really simple ASP page like the one I showed you there, but nothing of any actual use. So that was a bit of a downer. Web apps themselves can't run the ASP code natively. But of course, there's always another way, and the other way is this magic stuff, containers. So the rest of the talk is going to be on how we can containerize the customer's classic ASP applications, and therefore use a containerized version to run on web app for containers, which is one of the flavors of app service. So because containers, I'm not sure how many of you on the call here are familiar with the concepts and the practicalities of containers. I'm going to do is just do a brief segue into containers. So containers are a means of encapsulating the binaries, libraries, and dependencies for an application, but unlike a virtual machine, they share the same sort of host operating system rather than having their own copy. So in a virtual machine, there'll be a hypervisor and have its own operating system, and the reason it's called containers was likening it to shipping containers, which revolutionized the shipping industry by providing a standard sort of box in which to put things. And because these were a standard shape and a size, every point in the infrastructure knew how to deal with them. And that's very much true for containers, and specifically in the context of this sort of stuff, Docker containers. So that's kind of why containers are important. And for customers, the important thing about containers is, it says here NEOS, and what we mean by NEOS is either Windows or Linux. I'm not sure about other operating systems, but probably fundamentally that's true. And that you can have a Linux-based system or a Windows-based system. In the case of our use case, which is classic ASP, this fundamentally has to run underneath Windows. So, but lots of workloads don't need Windows, so why run them on Windows? So being a container, you can run it in a number of different places, and we like stuff to be on Azure, of course, and we have a number of destinations on Azure, but you can run them on premise too. You can run them on your laptop and whatever. So that's an important thing as well. And it doesn't really matter what the app is, and in many senses, it doesn't even matter whether it's a web app. So you can run something that is like running all the time on a container. But as I say, most people tend to run web apps on containers. And the other brilliant thing about them is they don't care what language you're writing the stuff in, because this whole thing of wrapping up all of the dependencies does wrap up the runtime. So whether it's Java, .NET, Python, Node, or any other stuff that you can think of that can run on in this case Linux or Windows, then it will work. And so that's the whole point. And because they're standard shape, the operation people can have common processes and procedures for operating the environments that are running containers. So this is probably, this is one of my last ones on what a container is. Now you need a recipe for building a container. Once again, apologies to those that are in the whole container thing. To people who are infrastructure people, hopefully this is kind of useful. So you need a recipe to say exactly how the container is built, and in the Docker world, this is called a Dockerfile, and it is a series of steps that basically say I'm starting off from this base image, and I'm going to install a series of things, and which eventually will include the actual code that you want to execute, but obviously it needs the runtimes too. And then we'll go, what do you then want to do with it? And in the case of this nice little one here, it's basically saying expose port 80, and HTTPD in this case is a web server on Linux. So that is a fairly standard looking recipe. It always would include the sort of the code that you want to install, as well as dependencies from the base image. And Dockerfile is absolutely central to this, and I'll show you the one that we built for this. And Dockerfiles build images, and when you run an image, then that is a container. So that's kind of one of the nomenclature things. So if we sort of move away from the sort of the theoretical, I'm actually going to step through this because I hadn't realized this thing I borrowed was animated, and it's not actually that much, not much help. So effectively, what you do is that you do either on your local machine, you do some Docker steps, which do a Docker build of an image, and then you push that image manually into a container registry, and then the runnable web app is configured to pick up the image out of the container registry that you previously put in there. And that's kind of the shape of any kind of containerized solution on Azure, in this case, where it's a web app. But in reality, most customers, as they sort of go through the maturity cycle, will either use a DevOps pipeline in Azure DevOps, or build stuff, if you're trendy and new, as a GitHub action. Yeah, and I might have time to show you a bit of a GitHub action. So in summary, it's the cloud native. And we need to do that because that's what is demanded by the customer. ASP doesn't run directly on the app services, so we need to Dockerize it with Windows containers, because ASP only runs on Windows active server pages. And then we're hosting it on Web App for Containers, because that provides the most managed experience of each of our solutions in Azure that can run containers. The most popular one is AKS, Azure Containers Kubernetes Service, excuse me. But the feeling with the customer, and in the sense the customer is right, it is right for them, is that Kubernetes needs a lot more tending to than does app services, and so that's why for this one we chose to do it on app services. But you could use most of this pattern and deploy the container on an AKS cluster, as long as that AKS cluster had Windows node pool. So that could be an alternative, but there's more for you to do and more to manage. We haven't talked about databases. Every app has a database, and there's some great tooling, which I won't really cover, which allow you to migrate SQL Server databases to Azure SQL Database. And once again, the customer wanted Azure SQL Database because that provides a nice platform experience where Microsoft manage most of the stuff the high availability, the backup, the point-in-time recovery, all that lovely stuff that is actually really quite hard to do if you're building it as infrastructure. And lastly, automate stuff in their case through DevOps pipelines, because if you want to reliably deploy stuff, you don't want to have manual steps. So dead simple for this particular solution, in that it's web app for containers here, which is just a type of web app. It's using an app service plan. I don't know why I've got shared written on there. If you have more than one web app, you can share the app service plan, so that's presumably why it's there. It's taking its image from container registry, which has been pushed there through a DevOps pipeline, and there's some other gubbins around here for managing secrets, and if you need to mount files into a container, and a SQL database Azure SQL database down here. So demo. This is the more interesting point now. So what I've got here in Visual Studio Code. Can you see my Visual Studio Code? Just Phil, yeah. Yeah, cool. Yeah, because jumping in and out of PowerPoint can sometimes not work. So what I've got here is a very simple application that is very much a kind of an active server pages thing. I've got bits of HTML, and I've got some embedded code, in this case, pulling some data out of a SQL database. And it is nice and ugly with all of this stuff in line. And this is like a sample app that is a really basic a single ASP page called default ASP, and it just happens to use a SQL connection to get some data from a SQL database. Now, so that's the kind of the app. The Dockerfile, which we discussed before, is kind of the most important part, because that's the recipe for how we build the container image. And what we can see from here at the top is the bit I'm highlighting. Is this basically says start your your image based upon this base image here, and you can see it's a Windows Server Core 2019 and a long-term something. It's long-term service version. The reason why this happens to be Server 2019, you could build your container image on some other version of Windows, but the app service that is the web app for containers won't run the container if it's not based on a Server 2019. Yeah, so that's important. And then you can see there's a whole pile of steps to install, in this case, IIS, and a whole pile of features on IIS, because this base image has got no other facilities on it besides Windows Server. And then install a whole pile of different bits into it, including all of the stuff that allows you to install the SQL driver, which obviously, if you've got any app that's doing anything useful, you need to be able to do stuff with SQL. And so the idea here is the Dockerfile encapsulates all of the steps that you need to, and in this case, finally add the actual code and stick it in a place called My Website in this case. And then this particular Dockerfile then runs up the web app in IIS inside the container, which will then be later running in web app for containers. So that's kind of why it's there. The point of what we're trying to do with this migrate is to make the minimum number of changes possible to the web app in order to make it run. So it's not a question of re-architecting or rewriting any elements of it. It's really the absolute minimum parts. And what I found with the customer, that the basic minimum parts were to basically grab out, I think, do I have it here? I don't have it on this one. The customer kept secrets, their connection string in their code, and the minimum changes we did were to extract the secrets out of their code, and the secrets in this case are the connection strings to the database, and inject those into here. And you'd in this case you would have a step called an env, which says I can inject an environment variable into here, and you can get the runtime to push in a value which you can then use later, so none of your code or your stuff has any secrets in it. And that's kind of an important step for sort of building Docker files. So that's kind of the Docker file. So the next bit is what do you do with this Docker file? And what you do is, let's see if I can find the right one without having to type. Yes, you generally do something like a Docker build, and what that's saying is using the dot here means using the Docker file that's in the current working directory, which is the same directory as the stuff you saw in Visual Studio Code. Do a build and tag it, and this is Midlands Azure user group number 4, and if I hit enter on that, what it does is it looks for differences, and it will go through each of the steps. If it's done those steps before and you've not made any changes, there are a series of layers inside the image, so you don't have to start from scratch. So that's actually built something and tagged it with MAUG4. And if we look at our Docker images, the nice thing is it gives you the most recent first. Yeah, well, I thought it would. MAUG4, you can see, and because I've not changed the code, it hasn't made a version change, and you can see there's like an image ID type thing here. It says there's no change. I'm just going to reuse it. The other important point here is look at these sizes. So for those that have done anything with Linuxy type stuff and Linux containers, you're used to little image sizes of tens or early hundreds of megs. These are quite large, and so this is 5.8 gigabyte image, and so that's kind of an important thing to notice, is that these images are naturally larger, and whilst they all work fine, they take slightly longer to deploy, and at runtime, and we'll see that in a sec, they will take up more space in your service plan. So you could probably have fewer of those running than you would if they were Linux ones. So that's one of the caveats. I mean, it doesn't stop you doing stuff. It just reduces the density of applications you could run on one shared service plan. So that's kind of the Docker build thing. The great thing is you can also you can also do Docker run, and Docker run allows you to run your application locally on your machine, so you can do all of your testing. And in the case of Docker run, you're effectively running up the container inside your machine here, and it's basically, I've got a bit of stuff here that says that the web server started, and if I find the right tab in my thing, I've got localhost 8080, and if I refresh that, I'm hoping it will actually run. So this is this little test app, and the little bit of SQL here is dragging out something from our nice AdventureWorks, whatever our standard test database is when you create a Azure SQL database. So this is doing something, and it's pulling in real data, and it's running. In this case, it's running locally. So if I go back now to and kill this thing, the general process then with any kind of containerization is that we've done the build of the local image. It's sitting on our machine here, and it's not anywhere on Azure yet. What you tend to then do is, if I can find it, you tag the image, and I think we did 4 last time. And what that's doing is it's tagging it so that my particular container registry is going to accept it. So we tag it, and then we push it up to the container registry. So what this is now doing is the version I've got there, I'm now actually uploading to Azure into the container registry, which is the first step of actually getting the thing actually deployed. Now, this happened here really, really quickly because I've not changed the actual image. So it goes, not much to do, so I'm skipping it. Off you go. If you do this first time round, it will take quite a few minutes because you're having to punt up a good deal of the 5.8 whatever gigabytes up to the container registry. Subsequent uploads will be quicker because it will already have the other layers in the image, and it will only need the newer layers. So if we actually go into our portal now, so we're now going into the Azure portal, and Azure Container Registry is where we keep all of our containers. We don't care whether these containers are Linux containers or Windows containers, and we don't care what those containers do. It stores container images for other Azure services to then be able to pull and then run them inside themselves, and we'll show that in a second. So the one that we just did was this one. If we click on it, and you can see that there's a few previous versions here, and 4 is the one I've just put up there. And there's not much interesting to see when you click on an individual one because it'll give you a bunch of stuff. But effectively, that's the image, and it will show you 5:29 GMT. Is that when I did that? I don't know. But so the image is in Container Registry. The important thing is it's available to be used. And so now I've got here a web app. So if I go back, this is kind of the if I just a bit perhaps slightly bigger, this is a kind of a standard app service. But I've when I created this one, I configured it to be a web app for containers using a Windows container. So looking in the resource group, you can see that basically I've just got in here the app service, and I've got the service plan that is the compute that runs the app service. So going back to the app service again, this looks and has most of the features that almost all the others have, and you can do deployment slots. There's all sorts of goodness inside app services that make it one of the most popular services on Azure. But in terms of what we're trying to do, talking about containers, and when I wait for it to display, you can see that effectively these settings in here are basically saying that my particular container registry, I can't even remember why it's called JJ News, but that's the name of it. That's the container registry, and you can see that it's got our image, and it's got version 3, but you can see in the list, I can now see version 4, which is the one I uploaded a few minutes ago. I'm not going to change that. It will take a few minutes to reload the image, and I think that's a bit of a watching paint dry thing. But if we click on the web app here, hopefully it will spring into life. Come on, yeah. So now this is this same image running inside an Azure web app. And this is Classic ASP. It's allowed to connect to this Azure SQL database. And remember, we talked before. If you start off with SQL Server, the easiest route is to migrate the data to Azure SQL database. That way, both parts of the app, the web app, as well as its data source, are both living in Azure, and that way it'll be efficient. If data sources need to stay on-prem where they are, you perhaps need to do some work in making sure at the network level, in making sure that the web app can route things down to an existing database. Can be done pretty straightforwardly. Depending on the design of the application, it may not run as snappily because of round-trip delays, between the Azure region and the the on-prem data center where the SQL Server database happens to be. But you can see we've kind of closed the loop now. This is the web app running inside the Azure App Services. One last thing I'm going to sort of show you. All of this stuff I've put in a GitHub repo here, which has been around quite a while, but the reason which kind of explains why and how to inject environment variables, so on and so forth, so that you can make sure that you don't leave secrets in the code or remove them, and how to access SQL databases here. But one of the things I've got in here is the automation of a GitHub action, and if I can actually see where the so this is all part of trying to automate the deployment, and this one is one that is automating those steps of building the image, making sure the image is in container registry, and then deploying it to an app service. And so there is several steps here. So we've got here build and push to container registry, and then I do a few things just to make sure that the web app can see the container image. And then here I'm effectively telling the web app now point to that image. So this is kind of the infrastructure. This is the equivalent of an Azure DevOps pipeline, but this is a GitHub action. So all of this stuff would be almost exactly the same if this was a Linux app, but this happens to be a really quite ancient classic ASP app that prior to this you'd have to have installed on infrastructure as a service. So I think I'm now just going to sort of move back into my PowerPoint slideshow and sort of essentially close up. So observations, for it to work, like I've said, the base image needs to be on server 2019. This is for Windows web apps on web app for containers. The images, the container images are quite large, and so if you kind of look in the amount of memory which I actually did forget to show you, if you look at the amount of memory the service plan is using, if we wait for this to display, yeah, I'm already using quite a bit of I think it's a P3v1 or something, to P1v3, yeah, almost. So you can see it's already taken quite a lot of memory, and that is because it's a fairly large container. I found in practice that the customer could get 4-ish classic ASP apps in one of these service plan instances, but once again, your mileage may vary. So they're quite large, but you can still have multiple apps. You have to inject settings, and there's a fairly unusual one with app services where if you name a setting, go back inside. There's a standard thing inside web apps where you can have a setting and wait for this to display. And because we're on a team share, it's slightly slow. If you've got a setting here, for example, where you'd put your connection string, when it arrives inside the container, it is this name with app setting _ in front of it. And that's slightly confusing if you don't know that. So that's a kind of good hint that this gets prefixed. Otherwise, as the web app injects the setting into the container, and so your container image, your Dockerfile needs to have an environment with the name app setting _ in this case DSN con, in order to grab the connection string that's being set in configuration. Another really quite interesting one, and that needs to be explained, is that Docker images in general, whether they're running in app services or AKS, are ephemeral. That is, if you alter anything inside the image, so for example, you write a piece of code which drops a file into the running container, as soon as that container restarts, that file's now gone. So if you had an app that needed to upload files, so for example, you're uploading photographs into a photo system, people's ID badges or something, if your code just dropped them into a folder inside effectively the running container image, then it would work and appear to work. But next time that image is restarted, that thing would no longer exist. And so what you tend to have to do in those circumstances is you can map an Azure file share onto a specific path inside the container, and effectively that file share takes over the role of that path. So as long as you can leave your code just the same, as long as your code expects to see it in a certain path, that path gets substituted in the runtime into an Azure file share. And because that's a file share, it will be persistent and it won't be ephemeral. So that was one of the fiddly bits that we had to do to make sure that for file uploads, you don't use them, because actually they appear to work initially. Yeah. And final thing is SQL Migration Wizard is really good and was very quick. So in summary, platform services can be used really effectively to deliver sort of a low management and light touch approach to getting classic ASP apps onto Azure with hardly any changes whatsoever to the code. And most of those changes to the code are stuff that shouldn't have been there in the first place. And in my particular customer's case, the connection strings in more than one place in the code. So Windows Containers works well on web apps for containers, but it has less density than normal apps, like I kind of said before. They take statically quite a bit of memory. The development lifecycle is absolutely identical to that of any other Linux containers. And then my final one is Kubernetes isn't always the answer. I absolutely love all of the Kubernetes and AKS stuff, but it is just more complicated, particularly for customers that are relatively new to, well, first of all, containers, as well as new to cloud and Azure. So this provides a route that is sort of simpler and more managed than either infrastructure approaches or a Kubernetes approach. So that's kind of my whiz through that. I haven't actually looked at the timing there. 38 minutes, not too bad. So we're at the any questions time.
Silence, John.
Oh, okay.
Big wowed everyone. Any questions? Oh, Lee, you got your hand up? Go ahead.
Oh, excellent. John, that was great. Very, very good. Quick question. Workflow-wise, because I do a lot of this work on a laptop PC, and I'm trying to figure out exactly this step, getting Docker containers into Azure. My personal workflow at the moment is I tried this approach with Docker Desktop, building the images, having it there, seeing things. But now I'm starting to find myself use the image within Minikube, the container, the Kubernetes tool, tag that, and then avoid having separate images built. Is that bad practice in your experience to save things like disk space and performance, to avoid using desktop and just use the Kubernetes itself?
I don't think there's anything that's bad practice. I mean, there always is a concern when you've got large images, how much disk space they take. And when I look on mine, I'm horrified at some of the images I've got on mine. With Linux ones, it's less of a worry because the images are naturally that much smaller. With the Windows ones, they are bigger. Now, one of the other things that we do see people starting to do is to use code spaces on GitHub, and that, if I can actually, show one. So on GitHub, I'm not sure where is it now. There is a thing in here. I've kind of lost where it is now, where you can your code spaces. So what you can do is you can create a code space based on one of your, I'm trying to find this one actually, Classic ASP Docker. This is typical, kind of, I go slightly, there we are, master branch. So what you can do is you can build up a development environment that isn't even on your box at all. And I think this is the way stuff's going to go, because kind of us a lot at Microsoft, and I'm sure you guys are the same, is you sometimes at home, sometimes at work, but quite often I've got a fairly chunky laptop at home or a desktop, and you want to do some stuff on that, and then sometimes you want to do something on a lightweight laptop or whatever, where you want to show somebody else elsewhere. And so what this is effectively, can I get rid of that thing? This is effectively Visual Studio Code running inside GitHub, but it's running in a container that then allows you to then do things like builds and everything else without there being anything on your desktop at all.
That's incredible. What platform is this? This is
GitHub Code Spaces.
GitHub Code Space. Oh, that is fascinating insight, John.
Yeah,
I have the same problem.
Yeah, I think this is the way stuff's going to go, because you kind of your browser is king. Then effectively you could do it on an iPad. You know, yeah. So that's something to look out for. I'm not quite sure of the GA status of GitHub Code Spaces. I've used it a couple of times, but effectively you can see it has the user experience of Visual Studio Code, all in a browser where it's effectively running on a set of dev containers behind the scenes that are just get activated when you use them and get deactivated when you're finished. And so you should be able to do pretty well everything that you could do on your desktop inside here.
That's wonderful. Much obliged for that. That's excellent. Thank you, John.